want to talk about scaling law, which, in my opinion, is the single most important discovery of our lifetime, and also the fundamental thesis behind Medra. In 2018, I started my PhD at the Stanford AI Lab because I had this idea that what if scaling law exists for robotics? If we can collect a lot of data in robotics, can we then train models and train physical intelligence, physical general intelligence, and achieve the sci-fi dreams I've always had since growing up? 3 years later, in 2021, I was going to join NYU as an assistant professor to start my own lab, and I was given the space and budget to fill a room, a whole lab full of robots, to collect a lot of robotics data to build robotics foundation models. That is until I got biology pilled. I started thinking, okay, if scaling law exists for language, like we've seen, for robotics, what if there was a scaling law that exists for biology? What if AI can reason about science? What if AI can reason about science with more data, can it reason about drugs? If it can reason about drugs, can it reason about actual cures? And if really scaling law exists, right? If we can generate more data in biology, could we actually eradicate disease in our lifetime? Well, there is actually a pretty big bottleneck to this kind of very simple calculation here, which is that right now, the amount of data that's probably required to eradicate disease will be more than 13,000 years of lab work. Let me just give you an example here. So AlphaFold, which was a biology foundation model for protein folding, came out from DeepMind, and it won the Nobel Prize last year. It trained on about 3 terabytes of data. But that 3 terabytes of data took more than 40 years of lab work to generate. Like actual people. When I say generate data, I mean like actual scientists in the lab doing really repetitive menial lab work. And then you look at O1, which I would say is like one of the true first reasoning models, right? It was trained on 1 petabyte of data, 3 orders of magnitude more data. If we want to reach scientific superintelligence, like scientific true reasoning, we might require around 1 petabyte data. At this rate, it would take 13,000 years in order to generate that amount of data. And that was why I left academia to found Medra, where we are building physical AI and robotics that can automate what scientists are currently doing inside labs and how they are currently running experiments to generate data. We are using general purpose robotic arms that have the flexibility of a human. And we're also using reasoning models and large language models that can also reason intelligently about the science. Combining these together, we have the flexibility of a human scientist, the intelligence of AI reasoning models, and the consistency of machines. So here are a couple big wins in the last few months. We actually just launched publicly as a company a month ago in September. We are currently hiring across the board in engineering and in ops. We are about to announce a pretty big partnership with a top 5 pharma, and we have actually deployed our system, our physical AI system, at several leading biotechs. And in 2026, next year, we're actually going to open our first lab. So instead of deploying systems to our customers, we're going to be building our own lab where we have hundreds of our own robots doing scientific experiments. So if any of this sounds interesting to you, even if you have no robotics background, no biology background, we're truly hiring across the board right now. Let's chat about robotics, AI, and disease eradication. Thanks, everyone.